Okay, right. So yeah, one thing that we can assume that this has a origin, or ju- the general case we can assume that this point as a, okay, so this is the O point as x, y, and z, a general point. So what are these points? Okay, x plus delta x, these points y plus delta y, and these point z plus delta z, right? Okay, let's back to the black color once again. So we have to calculate the vector field v, right? So we're gonna have this vx, and on that surface, obviously, we are going to have the value of x as a x plus delta, right? X plus delta x. What is the value of y over that? Okay, so uh, it depend upon a point. Okay, so on that surface, on the surface 1, the x has a fixed value, okay, which is equal to this, but y will depend upon where we are residing on this surface. Okay, so if we have at this point, then obviously the y and z is going to be 0, and this point the y and z is obviously going to be uh, 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 this y is y plus delta y, and z is z plus delta z, right? So we have this x and y, right? So instead of that, what we can write, we can write it as a y dash and z dash. So y dash will equal to 0 at this point, z dash equal to 0 at this point, but here the y dash and z dash is equal to y plus delta y and z plus delta z, right? And we have x cap. Similarly, we're gonna have this vy, okay, x plus delta x, right, and the other term. Okay, so we are not interested in other term. Why? You will see very soon. Okay, so let's calculate the flux. Okay, so let's phi is the flux from the first surface, okay, is equal to the vector field, right, times the area. Okay, area, right? So that is equal to the vector field times, or we can say the dot product of that with that. Okay, so area, the area, okay, area of or the area vector for the first surface is actually okay, so this is the delta y and this is the delta z. So it is going to be delta y times delta z, and the direction is x cap. Okay, so this is a vector when taking the dot product with this, so the only this component will survive. That's why I was not interested in the other components. So we'll get the vx, x plus delta x, y prime z prime times delta y delta z. Okay, so this is a flux from the first. Similarly, for the second surface is just opposite to that. Okay, so the second surface is for the second surface, that is going to equal to be vx, and in that case we don't have this x plus delta x, right? So this point is only the x. Okay, and for the y we have use of y prime z prime. Okay, and we have the x cap direction. Similarly, we are not interested in the other term because that is going to be that is not important or relevant while calculating the flux. Okay, and in the other term you can also assume that this v has the x component which is perpendicular to this surface 1 and surface 2, while the other component, which is the y and z component of this vector field v, will be parallel to this surface 1 and 2, so that will not contribute any any flux. So yeah, we have this now. If we are calculating the area of second, the area of second surface, so that is going to be delta y delta z, but we have this minus x cap direction. So what we are going to have this, now this phi 2 is actually v dot a of second, which is equal to the v of x y cap z y prime z prime times delta y delta z minus x cap. Okay, so of course this x dot x is obviously 1, but we have minus sign over there, so that means we gonna have this minus of that quantity, right? Similarly, we can write for the third surface. So what is this, where is this third surface? This is the third surface. Okay, so right, and one thing that we can notice from the naming that we have done, that this odd number of surface, okay, so this is the surface 1 is the odd number, so that will give a positive positive quantity, okay, there. And for the even number of the even surface, which is the second, give negative. Similarly for the third surface, we're gonna have the same thing, the phi from third, that will give okay, so this is the third surface, so only the y component of this vector field will contribute the flux. So we're gonna have this vy, and we have this x prime y plus delta y and z prime, right? And we have y cap. Okay, no, this is the v, this is the flux, okay, times the surface, okay, area vector third. So that will gives obviously dx dz y cap. So dx dz, right? Fourth quantity phi fourth. So that will gives minus of vy x cap y z cap delta x delta z, right? How we got this? So this is the fourth surface. So here the area vector is delta y delta z, and sorry, delta y I'm sorry, delta x delta z minus y cap direction, and that minus sign comes over here, and the direction of area is y caps. That's why the only y component of this vector field is will survive or will contribute the flux. Similarly, we can write it for the fifth surface and sixth surface. Flux from the fifth, flux from the sixth. So that will give v of z x cap y cap z plus delta z times delta x delta y, okay, and that is equal to minus vz x cap y cap z delta x delta y. So we have calculated the total flux that coming out of this cuboidal box.